Hello everyone, welcome back to this video series on software engineering. Uh, we have already studied about the types of softwares and the legacy softwares in our previous video lecture. Today we are going to learn about what is software engineering and what is SDLC, that is software development lifecycle. As per the definition provided on the slide, software engineering is the establishment and use of sound engineering principles in order to obtain economical software that is reliable and works efficiently on the real machines. That means that whatever software you develop should work on sound engineering principles. Now, what do you mean by engineering principles? That is software engineering principles. There are seven software engineering principles given to us by Barry Boham. He is one of the leading researcher in software engineering. We will see certain models designed by him, like Kokomo by Barry Boham, and many other things. There are certain principles like rigor is one of the principles which comes from rigorous word. Rigor means how much data or how much analysis you need to do for creating a software. Suppose the analogy comes that if there is a river somewhere flowing between two cities, suppose now you want to build a bridge over that river in between two villages, and if you want to build a bridge between two larger sea body, the rigorous activity that we do in both the cases differ, right? The number of peoples are deployed, the construction materials involved, the planning involved are totally different. Okay, depending upon what type of work you are doing, how you are doing, the importance of the work, the priority of the work, the rigorous activity changes. The second type of another type of software engineering principles include modularity. That means you divide the system into different modules, and then you want to create better softwares. Dividing something in modules actually helps in two ways. One is it standardize the coding process, and secondly it actually helps in debugging. So if you have different modules, you know which module is failing and which is working. So you need to or not you don't need to see all the code, you will see only that part of the code which is failing. Okay. So these are some of the principles on which you need to create your softwares. Secondly, whatever software you create should be economical in nature. That means it should be easy to sell and easy to buy in that particular system. And thirdly, it should be reliable and it should work efficiently on the real machines. Like we create software on simulators also, we create software on emulators also. But simulators and emulators are just softwares. They actually simulate or emulate a particular type of environment, right? But actually the software will work on a real machine. So whatever thing we create on simulators, even we should be able to deploy the same system in the real world. Any engineering approach must rest on the organization commitment to quality. That means all of your work that you plan to do or whatever work you do rest on the fundamental block of quality, and everything depends upon quality. The layered approach of software engineering is shown here. If you see that there is a quality focus as a bedrock of a particular system, this approach, that means everything rests on this quality parameters, right? So if I want to buy a particular uh, cloth or a particular piece of article, what I will do, I will find a place, I will find a shop which gives me a better quality, right? So this is the human nature, that he will always he will always go after the quality, right? And if there is a minor mistake in the quality, I will not prefer this, even if it is less costly, over the one who has better quality. Okay. Now, how does quality comes into how you maintain quality? The first thing is how you maintain quality. You maintain quality because you follow a process. If you follow a process, you will always maintain a quality. The example to this is many of you have visited, I believe, McDonald's and other uh, chains of food vendors that gives excellent foods across India, across world. So if I give you an example of McDonald's aloo tikki, how they maintain the same taste across, even if you take the same product in Noida, if you take the same product in London, if you take the same product in Hyderabad, if you take it from anywhere, the taste remains the same. Why? Because they follow the same process, exactly the same process, what they use everywhere. Okay, so this is how actually it happens that when you take a process, when you stick to a process, you with rigor. Okay, then then the quality is same. Okay. Now the other example is many of you are fond of eating uh, Maggie, okay, or noodles, whatever the case be. So they provide you now with a ready to taste type of uh, ingredient along with the Maggie, 2 minutes Maggie. Why do this? Why they want to do this? Because the thing is they have written a complete three-stage process. If you have overlooked, if you have turned the packet of the noodles or the Maggie that you have, and you see it, you will see that they mention clearly that there are 3 steps of creating a good quality product. The step 1 is this, step 2 is this, and step 3 is this. And in this 3 step, the second step include the mixing of that ready to taste ingredient in that particular order. So they mention the process very clearly, and the why they have given you that ready to taste, because you can also create it at your home because the ingredients are written at the back of the packet. But the thing is, if you yourself start creating it, you might the ratio is different, right? So that's the reason they want to standardize the process. They want to give you a standard taste. It might be a little less or a little more because you don't follow the same process. But in what I want to focus here is to maintain the quality across all the values, you need to have a standard process. Okay. So the third, how you implement a process? You implement a process using a certain set of methods. Okay, the methods might be different. The process for making a tea is you mix 4 basic ingredients like milk, tea, water, sugar. Okay, you have these 4 basic ingredients where you put it with which you create tea in India. Now, the taste of the tea comes from the process, okay, from the method. Okay, you apply a certain set of different method. The process remain the same. Mixing of this thing will be different, and you get a different quality coming out, right? Totally. So the methods are required to implement a certain type of process to achieve a standard quality. Now the methods itself can be implemented through multiple tools. You can use multiple ways of creating that particular maintaining the quality. So you use multiple tools to implement these process methods, and that to in turn implement the process, and that will impact the quality. So this is how the layered approach actually works in day-to-day life as well in software engineering. So whatever we study in this course of software engineering, you can easily correlate with your day-to-day life. Now, let's move on with the approaches to maintain quality. There are 2 approaches to maintain quality. The first thing is called total quality management, and this is TQM, and the other is called Six Sigma. Both are required to maintain quality, but TQM generally says that if I deliver a product with a certain quality to a customer, I will try to maintain the quality. My focus is to maintain the quality. Okay. In Six Sigma, what I do if I deliver a particular set of a product, a product to the customer for certain quality, I will strive to enhance the quality and then monitor so that the quality is enhanced or not. I will do it in a very controlled manner. Okay, so Six Sigma has five stages. One is defining the requirements, measuring the criticality, analyzing the problem, improving, that means mitigating the root cause. That means if you have an issue, I will to remove the issue with the root cause so that it never happens again. And finally, I want to control the sustain the improvement. That means I will control, I will check, and I will monitor it, and then I will ensure that the quality has increased or not. Okay. So these are the two approaches to maintain quality. We will see some of this when we study software quality. The foundation of software engineering is the process layer. I have explained. Upon quality, there is something called process. The process defines the framework that must be established for effective delivery of software engineering technology. So you need to have a certain set of processes which actually maintains the quality, and it is helps you in delivering the software effectively. It forms the basis of management control of software projects, establishes the context in which the technical methods are applied. It takes care of the work products that are generated. It establishes the milestones, ensure quality, and manages changes in the controlled way. So these four are the importance of software process in the context of the layered approach that we studied. So it actually, if you have a process, the process says that first of all the system will developer will enter up, like I will give you a practical example. When we work in industry, so we need to do coding, we need to do testing, we need to do documentation, we need to do rework also. Okay, rework means once you write or when you written a code, the code goes to the tester for testing. He finds out the error. He gives you back the code and you rewrite the code. Okay. Now the difference between rewriting of the code and developing a code is different. The reason is the process says that you will write a code, you will test the code at your end, then you give the code to a tester, the tester will test the code, then you package the code and you document the system and you deliver it. Okay, these are the some stages, straightforward stages. Now what will happen if you write the code, you send the code to tester, the tester sends it back to you and you rewrite the code. Okay, now in this case, this reverse flow is hampering the process of software development. Why? Because the customer is paying you, the customer has paid you for developing a code, okay, and for testing the scenario, for documentation, for implementation. He has given you the money. Now what you are doing, your team is now writing a code. Yes, very fine. You entered that I have written, I've development workforce is 5 hours. Okay, then you enter that I have put my 2 hours for rewriting the code. This 2 hours is is a penalty on the team. Okay, this was not part of you. This shows that either you are not trained or you are not efficient in writing the code. Okay, so the management control, actually this process tells you that okay, I need to focus more on the training or the expertise of this particular resource. So this is how we actually improve the process, by finding out where we need to work more and where we need to work less. Second is it establishes the context in which the technical methods are applied. So we will understand that these are the technical methods that should be applied. These are the technical ways in which you should achieve that particular set of work. So for implementing a process, you might have multiple methods, right? Multiple ways. So you will choose one of the ways to implement the process. Okay, sometimes it happens that you implement a particular process with certain set of steps and these steps are not optimized or they are not efficient. So you will choose another method to implement that, and that is much more efficient than the previous work. So it also takes care of the work products that are generated, like models, documents, data, reports. Okay, the process actually tells you what will be generated in which part of the process. So if you are doing coding, the code will be generated. If you are doing documentation, the documents should be generated. If you're doing a testing, the test plan should be generated. So it tells you everything. So in overall, it tells you how to maintain quality. Now, in the next lecture, we are going to study about SDLC and the steps, the stages that SDLC actually takes care. Thank you.